Okay, so I'm going to advance this concept even further. And if you're familiar with the part one and two of this experiment, I started out with rocks in a bowl, and I did a smaller version of this with these tea light containers, took the wax out, and put a little copper top on the top of it for the positive. And then the sand is in between. So this is kind of a smaller version of the rock in a bowl. And we're going to even go smaller than that. So I've got these pennies, and the pennies that are 1982 or later have just a coating of copper on the outside, and then the inside is mostly zinc. There could be some other pennies that are a mixture of other metals, but a lot of pennies nowadays are just copper and zinc. So I'm going to utilize this, and I'll just show real quick what I'm trying to do. So in these batteries that I made with the sand batteries, the tea light, so I have my aluminum metal for the negative. I have my sand for the material in between. I put some water in there. So it's wet, and then I put a copper top on it for the positive. So I had my battery, I got a little bit of charge out of that, and then I put them all in series, and I got some power out of it. I got some LEDs to light up, and that was the last video. So basically I'm going to do that same concept, just make it smaller with these pennies. So on one side I shaved off or sanded off the outer coating of the copper, and on the other side it will be just the copper coating. So I have the two metals. So basically what I'll do is I'll have this as the bottom. I'll put a pinch of sand on top of that. Do a drop of water. And then I have a top for the positive. So basically I just did the exact same thing as this, except for now I have the negative again right on there. So now I could just put some sand right on top of that. A little bit of water. Just making sure it's all on there. I mean, I need an eyedropper or something. So now we have another one to go on top. And the sand granules are not going to be all the same, so you kind of have to do another one on top there, and just repeat the process until you have the copper goes down, the zinc side is up. Just remember the copper side is down. Let's do one more. And there you go. So basically, I did this exact same thing and then stacked all my cells up just like this. So the penny with the two different metals is acting like the positive and negative, positive, negative, positive, negative. It hooks everything up together with the sand in between. So that's basically the same thing. So now I'm just gonna see if I have power from that. And this is just thrown together, so very rough, but you'll get the concept. And then from here, if I have some success, then I'm gonna move on and make it better, cleaner, and see what other ideas I can do with it. I'll just kind of lean it in there so you see the multimeter. So I'm going to put my leads on there from the multimeter and see how much power we get from this. I don't know if you can see that. So I'm getting some. I'm getting almost 2.5 I saw in there. I'll hold it still, about 2.7. So I got about a consistent 2.7 volts from that. So, and if this is cleaner, I'm sure it'd do better. This probably need better contact, better sand, better whatever, I don't know. So that's one test, and then I'll do like another little light test on this and do this, see if you see it flickering. There you go. Alright. You see that flickering, so that's positive. It's a positive test. Okay. See if my America flag will work. You can kind of see it, the red one. There you go. Okay, so a positive test. I actually wasn't surprised because I already did this, but when I did it the first time, I was actually very surprised. This is a simple little experiment that you could do. Kids could do this, but if you want to just do this and see where your imagination takes you, of what the possibilities are, and obviously you could use better materials than this, but this is just accessible right away. I mean, you could just get these in your couch, and everybody has sand everywhere, so there you go. We'll see where this goes. Now I've got these pennies really cleaned off from that one side of copper coating. So I'm actually curious right now how my battery would improve. So I'm just going to stack this over again with the, maybe I'll start just with that. See, I'm doing that down this time. Okay, that looks... So I'm just going to do that, stack them all up, and see how much power, see how much more power I have. More, it should be more than 3 volts, I think. There you go, the last one on there. I did this a lot cleaner now. Cleaner contacts and everything. So we can see those numbers. Let's do a quick little test. 3.3. This is negative 3. I need to switch these around. Alright, so about 3.3, 3.4 volts. So it did improve it. Cleaner contacts on there, and now let's just get this to light up a little bit. It needs to be turned around here so I can think. There it is. There you are, a little light. I just love watching that. It's so cool. Anyway, let's so there's the concept. Just leave it a little smaller than that. And you can see where I'm going with this. Better contact with metals. That's a different thing. And so you can kind of see why people start using graphite. Because graphite has the 2 properties with it that acts like a metal, where it's conductive, and it also acts as a mineral, which it holds a charge. That's the thought of that. And then some people go even further with graphene. Graphene is the more refined version of that, and graphene is as thick as a molecule, so it gets really, really thin, and then they just get these cells smaller and smaller and smaller, so you could just keep stacking them, all the cells that you want, all up in series, and then it'll have the capability of just getting whatever power you want out of it, and it has a self-recovery factor. So the same guy that made this graphene supercat module, the quantum mechanics guy, he uses graphene in his capacitors, and so you get all of the stuff that I'm talking about, except for he's using graphene. So the potential of this concept is with graphene is just amazing. So he's also working on another self-charging battery bank type of thing. You'll have to watch that video, but basically it's a little module that's probably half this size, like a black box, and you could charge your cell phone, you could charge other things with it, and it has a self-recovering charge, so you never have to plug it in or anything, and it's based off of this concept. So if you understand this, you could start to understand using graphene and supercap, very, very small cells in series, and just getting it to get all the power you want. So I'm going to see if I can get this in a tube and just get a whole bunch of these stacked up. I don't know how far I get with this, but at least I got it to light up. I know it'll work if I get it set up, because it already lights up something. So